for both sides. So I'm going to do both. I'm going to do some of this and some of the other one. So I'm going to start this one with a lesson on at the board. Next time I will do one. It may not alternate directly back and forth, but it will be, I'll do some of the board and some at my desk, so you get some of both. All right, so this is rational exponents, okay? So yesterday we did an activity that dealt with the exponent rules, so hopefully you remember all of those, all right? So rational exponents, the word rational actually means when we deal with fractions. Is board not working? Try this one. Oh, there it goes. Okay, that was weird. Let's see if this works now, or is it? Okay, well, let's try this. We have fractions, or is it not going to write as I write? Oh, that's going to be really annoying. So we'll see how this works for the next couple of pages, but we might go back to the other format. Okay, so here is our notes, and they did not show up all the way, so I'm going to go back to normal screen. Okay, so just a couple of things about fractional exponents I just want to point out. First of all, I want you to realize that the square root of x is also simply the variable to the 1/2 power, okay? Now we can deal with many, many different types of roots. It's not just square roots, and this is where we had some trouble earlier, which is why we're going over this now, is the fact that we can have a third root, okay? We could have a fourth root. Right here it gives us the general formula. So if I were to have, say, the sixth root of x, that would be x to the 1/6 power. Okay? So this is going to help us deal with these because we can deal much better with exponents than we can with radical symbols. Also realize here, I want you to look at this one here, this a to the 2/3. Okay, the 3 represents the root and the 2 is the power, so it's the third root of a squared. So let's look at some examples of how this works. All right, so we want to write this as a single power of 2. So in a lot of these, if your questions are going to ask things like this. So if I have, see if we can go back to full screen now. Okay, so I have, essentially, I can rewrite this using a fraction on the exponent. So I can write 2. Okay, guys, I'm going to apologize. There's obviously an issue when I go full screen. So we're going to change it back to the normal screen. It will be a little smaller, but we can still see it. Okay. So I can change this to 2. Sorry, the board's being all weird. Right, so we're going to do 2 times 2 to the 1/2, okay, because the 1/2, the 2 is, the radical of 2 is 2 to the 1/2. So the power that's on this 2 is 1, or I could also write it as 2 over 2. Now remember my exponent rules. If I have 2 bases that are exactly the same, okay, I can also then change the, I can then add the exponents together. This becomes 2 to the 3 over 2. And that is my answer because it asks specifically to write the answer as a single power of 2. All right. So here's your practice problems. Notice there's more than one. Okay, I did that on purpose so that you have an opportunity to practice these problems. The answers will be on the next slide, but try them on your own first. Here's your answers. Okay, so now, there's lots of problems they're going to ask this specifically. They're going to say without a calculator. Okay, without a calculator, try to write this. Now this asks to write it in the simplest rational form, okay, which means that we'll have an exponent and not a radical symbol. All right, and it gave this problem 4 to the 3 over 2. Now, what I want to do, if it wants it in the simplest form, I'm going to see, can I change my base to something simpler? In this case, 4 can be changed to 2 squared, all right, and then also then it's still to 3 over 2. Now when I have powers raised to powers, okay, I multiply them together, and please remember when I multiply together, I cancel. So this is going to cancel with that. So my answer that I get is 2 to the third power, which is 8. And you should be able to do that out without any calculators, okay? So here is your practice problem, okay? Remember, change the base to something simpler, and you will you'll find your problem much easier. Here's your answers. Okay, example 3. Now, I actually do not have a practice problem 3. We're only going to go through example 3. Now, this is what happens when we have problems all built within each other. All right, so there's all kinds of radicals and rational exponents and all kinds of things. So I'm going to change everything to rational exponent, and I'm going to actually put each exponent on each piece. So you'll notice here, this 1/2 goes to both the a and the 6. So I'm going to go 6 to the 1/2, a to the 1/2, okay? And then the radical symbol also represents 1/2, so I have a to the 1/2, b to the 1/2, okay? All over a squared, b to the 3 over 2. So before I start simplifying across the fraction line, I'm going to simplify inside first. So this is 6 to the 1/2 can't simplify, so I will just leave that as 6 to the 1/2, okay? A to the 1/2 and a to the 1/2 is 1/2 plus 1/2, which is a to the 1, so I don't have an exponent, and then b to the 1/2, all over a squared, b to the 3 over 2. All right, now I'm going to look at simplifying my exponents across the fraction line. This a right here, we're going to subtract, so I'm going to go 2 minus 1. So on the bottom of my fraction, I have 6. So 6 goes on top. So that will change in just a moment. The board's being very difficult. I apologize for this. Okay. So all right, we're just going to cross all out and start over. Okay, so I have 6 to the 1/2 on the top, and then a to the first power will go on the bottom because 2 minus 1 is 1. And then this is going to be 3 over 2 minus 1 over 2, which is 2 over 2, so it's b to the 1 as well. So this is my answer. It could also be written like this. Okay? Either one of those are acceptable. Okay? So there is no example for this one. The assignment will be in class tomorrow, and I will see you then.